Here's our second example on sketching the graph of an exponential function. Here is the function. I have negative 2 times 3 to the x plus 1 power plus 2. Notice that I will have a reflection in this function, okay? So we have to be very careful about this. And also notice I have a plus 2. That means I'm going to move up 2, which means my horizontal asymptote will move 2 upwards also, okay? From my parent function, I know that in the parent function, my horizontal asymptote is at y equals 0. So if I shift this graph up 2 times, my horizontal asymptote will shift up 2 times with it, okay? Also notice that the base here is greater than 1, so that tells me this function is increasing initially. When we reflect it, then it's not going to look like this. It's going to be reflected, okay? We'll see that. Let's start. First thing I like to know is we just said it. This is the first step right here. We want to know if it's increasing or decreasing. Okay, just to have an idea or a reference of how my graph will look at the end. Okay, so for now my reference is that it's increasing. Okay, the second thing I want to find is my y-intercept. Your y-intercept. How do we do that? We evaluate the original function at x equal to 0, and that gives you negative 2 times 3 to the 0 plus 1 power plus 2. And that equals negative 2 times 3 plus 2, which is negative 6 plus 2, which is negative 4. So your y-intercept is at 0, negative 4. Okay, and the last thing we want to find is our horizontal asymptote. And we said that our horizontal asymptote will follow my vertical shift. I have a vertical shift of 2. That means my horizontal asymptote will also move 2 units up. So I will find my horizontal asymptote at y equal to 2. Okay, so now we're going to start plotting these things on my graph. Let's plot our y-intercept. It's at 0, negative 4. So 1, 2, 3, 4 right here. That is my y-intercept. My horizontal asymptote is at y equal to 2, 1, 2 right here. That is my horizontal asymptote all across this line y equal to 2. Okay? And I know that my function initially my function was increasing. So that means that this is what my function would have looked like initially. Something like this. Increasing that way and getting closer and closer to the y equals 0 asymptote, but in this case it's my y equal 2. Okay, so I'm getting closer to this asymptote and moving up like that. That's my original reference. Now since this is reflected, and notice this negative is outside of the function, so this means it's a reflection across your x-axis. But in this case, in my parent function, the x-axis is also the horizontal asymptote. For this case, since my horizontal asymptote moved up 2, now I'm going to reflect across my horizontal asymptote, okay? So here's my horizontal asymptote. I'm going to make believe that I folded this paper across this horizontal asymptote, and the reflection that I get will be across that asymptote, okay? So it's going to go somewhere like this, and here's my y-intercept. So like that. And on this side, I will approach my horizontal asymptote closer and closer to it. And there it is. I'm sorry about all these squiggly lines. Just trying to make it look better. But I think I'm making it look worse. Okay, you get the idea. Okay, so there it is. This here doesn't look like a perfect reflection because this function that I drew here, I'm just, this is just a sketch. I didn't look for the y-intercept here. This y-intercept is somewhere up here. Okay, this doesn't matter. This is just a reference so you know that this is going to reflect this way. Okay, so don't worry about this not looking symmetrically reflected like against this one, because this is just a rough sketch to let you know that it was increasing and now it's going to reflect that shape and it's going to go through this y-intercept. If I had looked for the y-intercept here, this would look better. Okay, but that's not part of knowing how to sketch, so I'm not going to go through the trouble of finding the y-intercept before this is reflected, which is going to be at 8. 1, 2, 3, 4, 5, 6, 7, 8. So my graph, this blue one, if I had made it a little bit more precise, this is what it should have looked like. Going through this y-intercept, okay, and not this one. So okay, so forget this one. But remember that this one doesn't have to be perfect. It's just a reference so you know that you're going to fold and this is what you're going to end up with, and make sure your sketch goes through the y-intercept that you found. Okay, if I had sketched this correctly like I did the second time here, then now it looks more symmetrical. Okay, so just so that you know it's not a problem. Also, let's do domain. Let's not forget domain and range. So the domain for this one, again, I have any x value because this graph will continue all the way that way and all the way this way. That will include all of these x values all the way to infinity. I will have a matching y value for the graph anywhere on this axis. So that means your domain is all real numbers, or from negative infinity all the way to infinity. For your range, remember, we sweep all the way from negative infinity. Notice I do have a graph down here from negative infinity all the way to where it stops. It stops right below the asymptote. So that means that my range will be from negative infinity all the way to 2. And that's where your graph stops, y values. It keeps having y values infinitely close to your asymptote, but it will never go to a y value equal to 2 or any value above y equal 2. Okay, it's not going to be anything above here. So that's why it stops at 2, and it's in open parentheses because it doesn't include 2. I hope you understood this example. The next example, we're going to reflect up here. We're going to have a negative at the exponent, which is a reflection across the y-axis. Okay, I'll see you in the next video.